Next, I think it's worth talking about a function where the limit does not exist. There's no better example than the one that the book has. So I'm going to look at the complex conjugate of z over z as z approaches 0. And this can't equal a particular number because remember what's happening here. First of all, this function is defined on all non-zero complex numbers. So our domain is going to be all non-zero complex numbers. This has the same graph as before, so nothing terribly different there. But let's just draw it just so that we can talk about this. So every non-zero number there. Now, 0 is an accumulation point of this set, so it still makes sense to talk about the limit as z goes to 0. The reason why 0 is an accumulation point is that if 0 is the only point removed, then no matter how small of an open disk you have centered at 0, it's going to contain some points of g. So 0 is still an accumulation point. It still makes sense to talk about the limit here. What we're going to do though is let's just draw a open neighborhood here. Okay, and so that's going to be some ball of radius, say delta. Make delta as small as you want. Okay, so that distance there is going to be delta. And that's the distance from, just to be clear, from the origin to a point on the boundary of that ball. Okay, it's an open ball, but there we go. And what we need is for all points in that disk minus the origin, we want them to follow the pattern that if we stay sufficiently close to 0, then our outputs are sufficiently close to whatever our limit is. The problem is that it depends on whether you approach according to a certain path, what your limit's going to be. So for example, let's look at, so let's say z is x plus iy. That means that we're looking at the limit that x plus iy approaches 0, where the conjugate of z is x minus iy over x plus iy. So again, z conjugate over z. And so let's think about what's going to happen if we approach when x goes to 0, but y is 0. Okay, so that's a possibility there. So we could look at the limit as x goes to 0 if y is 0, and that's just going to be x over x, which is 1. We could look at the limit of y going to 0, but where x is 0. And if that's the case, we're going to get the limit of minus iy over iy. And so the y's will cancel, and we'll have minus I over I is negative 1. You could even look at something like, in general, you could look at, say x equals y. So x equals y, where one of them is going to 0. And if that's the case, then you're going to look at x minus ix over x plus ix. And you have to be a little bit careful here, but you can factor an x out of this, and you'll end up with 1 minus I over 1 plus I. Okay, so you end up with, let's see if I want to see what that number is actually. We can multiply top and bottom by 1 minus I, and that's going to make the top, let's see, 1 minus 1 minus 2I, and the bottom will be 1, so we get minus I. Okay, so according to this path, if x and y are equal, then the limit's going to be minus I. And so what happened here was we were looking at different paths. So I'm going to make the paths purple. But if y is equal to 0, and we're on, say, so that puts us on this axis. So if y is equal to 0, just kidding, that puts us on this axis. If y is equal to 0, and then we're letting x approach 0, whether it's from the left or from the right, it doesn't matter. As we approach according to those horizontal paths, our function is going to approach the quantity 1. If we approach from, let me give another color. If we approach from, so this was the purple path. If we approach from this pink path where x is 0 and y goes to 0, then from that angle, our function is going to approach negative 1. And if we approach, say, using according to the where x equals y. So that means along this path, so at a roughly 45-degree angle, then our function is going to approach negative I. So all of this is to say that the limit doesn't exist because different paths towards the origin give you different outputs. Okay, so this is exactly the behavior that we don't want for a limit. Okay, so here the limit of the conjugate of z over z is z approaches 0 does not exist.